Let's talk about acceleration. Acceleration is the rate of change in your velocity. So if you're changing your velocity, then you are accelerating. You can change your velocity, remember, by changing your direction. That would change your velocity, or by changing your speed. Because acceleration includes direction, that makes it a vector quantity. You can actually change your speed and direction at the same time, of course. But either one of those will change your velocity. So you can change your velocity if you're driving in your car east at 20 meters per second. Let's say you're going 20 meters per second east and you go around a curve, so that now you're going 20 meters per second south. You've changed your velocity. So this is acceleration. Just going around a curve, even at a constant speed, is acceleration. Also, if you're going east at 20 meters per second, and then you slow down so that now you're going 15 meters per second, but still east. That is also acceleration because you've changed your speed. We often think of acceleration as meaning to speed up, but you're not always speeding up. You can also slow down or change directions. The equation for acceleration. The simple version is the change in velocity over the change in time. To get the change in velocity, we're going to take our final velocity and we're going to subtract our initial velocity, so the velocity when we started. To get our change in time, we're going to take our final time and we're going to subtract our initial time. Right? So acceleration equals Vf minus Vi over Tf minus Ti, where Vf is our final velocity, Vi is our initial, our starting velocity, Ti is our initial time, and T sub f is our final time. There are a couple types of acceleration. We can have positive acceleration or negative acceleration because acceleration is a vector. So the direction of the acceleration is going to tell us if it's positive or negative. Either one of those things can slow us down. If we have a positive acceleration, we could still be slowing down if we were originally going in a negative direction. So if, for example, we're going downhill and we slow down, that would be a positive acceleration, right? Because here we are going down a hill and our acceleration is slowing us down. It's pushing against the direction we're going. So our velocity is positive, but our acceleration is negative, right? We could also have a positive velocity, a positive acceleration that speeds us up. If we are traveling north and someone pushes from behind, right? If we're traveling northward and someone comes along and gives us a little boost, our velocity is positive and our acceleration, that boost, is going to push us in that same direction, so we're going to speed up in the northward direction. Okay? We could also have a negative acceleration if the direction of our acceleration is negative. So we could slow down with a negative acceleration, right? Let's use that same example of going northward. If our velocity is positive here, but instead of getting a push from behind, we get a push from in front or southward, a southward push. That would slow us down if our acceleration then was southward. But a negative acceleration can also help us speed up if, for example, we're going down that hill and someone comes along and pushes us down faster. So the direction of the push, the direction of the acceleration is negative, it's downward. We're already going downward, so we would actually speed up, even though our acceleration is negative. So this is if we were going downhill. And we get a push from behind. Okay? So basically what this is telling you is that if your acceleration is in the opposite direction of your velocity, you're going to slow down. If your acceleration is in the same direction as your velocity, you're going to speed up. Again, here our velocity is positive, but our acceleration is negative, so we slow down. Here our velocity is negative, our velocity is negative and our acceleration is negative, so we're going to speed up in a negative direction. Okay, so keep in mind that a negative acceleration just means that you're moving in a negative direction. The change in motion is towards the negative direction. If you're already moving in a negative direction, you will speed up. If you're moving in a positive direction, but your acceleration is negative, that means you're going to slow down because you're going to be moving more towards the negative direction than you were. Let's do some examples. Change my color so we can see. Okay, so we've got a plane that starts at rest. So if it's at rest, that means that its velocity is 0. And its time is 0. And then it reaches a velocity of 80 meters per second in 20 seconds. And we want our acceleration. So we know our acceleration is VF minus VI over TF minus TI. Our acceleration we don't know. But our final velocity, it says we reach a velocity of 80 meters per second, positive 80 meters per second. So that's our final velocity. Our initial velocity was what we started at. We started at rest, 0 meters per second. Our final time, it tells us, it took us 20 seconds. So that's our final time. Our initial time, it tells us, was time 0. So then we can plug in A equals 80 meters per second minus 0 meters per second over, now we plug in our time, 20 seconds minus 0 seconds. So then we get 80 minus 0 is still 80. 20 minus 0 is still 20. So we get that our acceleration, 80 divided by 20, is 4. So we get a positive 4 meters per second per second. Look at that unit. Meters per second over second. That's the same as saying a positive 4 meters per second squared. Okay. So our units for acceleration, you're always going to have a distance unit over a time unit squared. Or you can write it as a distance unit over a time unit over a time unit. Either way works out the same way. Okay, so here we've got a positive acceleration and we are speeding up. You see we started at rest and we speeded up to 80 meters per second. That means we've sped up and our acceleration is positive, right? Okay, let's look at this one. A plane starts at negative 30 meters per second at time 0 and reaches a velocity of negative 50 meters per second. Okay, so right there, I'm starting at negative 30 meters per second and moving to negative 50 meters per second. Right there, I know I am speeding up because I'm going from a speed of 30 meters per second to a speed of 50 meters per second in a negative direction. So I know I'm speeding up. Since my velocity is negative and I'm speeding up, I should get a negative acceleration. Let's look and see if we do. So the question is, what's the acceleration? Acceleration is VF minus VI over TF minus TI. My acceleration, I don't know. VF, my final velocity was negative 50 meters per second. My VI, was negative 30 meters per second. I ended, let's do TF first. I ended at 10 seconds. So my TF is 10 seconds, and my TI, it says I started at time 0, 0 seconds. So when I plug in, I say acceleration equals negative 50 meters per second minus negative 30 meters per second over 10 seconds minus 0 seconds. So when I do that math, I get acceleration negative 50 minus a negative 30 gives me a negative 20 meters per second over 10 seconds. So my acceleration is a negative 2 meters per second, or negative 2 meters per second squared. So I thought I should get a negative acceleration, and I did, so that's good. Let's look at acceleration when we're slowing down now. Those two were examples of speeding up. Now we're going to slow down. Here we've got a plane that starts out. So I know I'm starting out at this velocity, so that's my VI. And then it comes to negative 20 meters per second. That's my final velocity. And it takes me 2 seconds. That's my time, my final time, 2 seconds. To define my acceleration, I say acceleration is VF minus VI over TF minus TI. My VF, my acceleration, I don't know. But my VF, I've already said that it was negative 20 meters per second, and my VI is negative 40 meters per second. So I know I'm slowing down because I started off going 40 meters per second in the negative direction and ended up going 20 meters per second in the negative direction. So I'm not going as fast as I started out going. So since I'm going in the negative direction, I know that my acceleration should be positive. My TF is 2 seconds and my TI is 0 seconds. Plug in. Negative 20 meters per second minus negative 40 meters per second over 2 seconds minus 0 seconds. And I get negative 20 minus negative 40 gives me a positive 20 meters per second over 2 seconds. So my acceleration is a positive 10 meters per second, or positive 10 meters per second squared. And that makes sense. I'm slowing down in the negative direction and my acceleration is positive. One more example. Here we've got a plane that starts at 50 meters per second, a positive 50 meters per second. That's my VI, because that's where I started. And it comes to a stop. Stop tells me that my velocity is 0. Right? It takes me 25 seconds. So to find acceleration, VF minus VI, TF minus TI. Where? Acceleration, I don't know. But my VF I know is 0 meters per second. My VI I know is 50 meters per second. My TF is 25 seconds and my TI is 0 seconds. If they don't tell you a starting time, you can assume that that starting time is 0. Since I'm going from positive 50 meters per second to 0 meters per second, I know I'm slowing down. I'm going in a positive direction and slowing down, so I should get a negative acceleration. Okay, let's work it out and make sure that that's right. My final velocity is 0 meters per second. My initial velocity is positive 50 meters per second over, 25 seconds minus 0 seconds. 0 minus a positive 50 is a negative 50 meters per second over 25 seconds gives me a negative 2 meters per second per second. And that makes sense. I'm going in a positive direction but slowing down, so I have a negative acceleration. All right, let's talk about a constant acceleration. If you have a constant acceleration, this means that you're accelerating at a constant rate. This does not mean that you have constant speed. This would mean that your speed or your velocity is changing at a constant rate. So it's not a constant velocity. Right? You can actually be moving but not accelerating. This is like when you put your car on cruise control. Right? So this means that you have a constant speed and a constant velocity, constant direction. Okay? So you can be moving but not accelerating. But you can also be accelerating without moving, meaning that you would have a 0 speed. You can do this by changing directions. Think of a ball at the top of a free fall, or top of a throw, rather. When you throw that ball up in the air, right there before it starts to come back down, right here, it actually has a 0 speed. It's perfectly still, but it is changing directions from going up to going down. So it has acceleration even though it does not have speed. Okay? So when we're talking about a constant acceleration, we mean that you are changing your velocity in some way. And it's the same way consistently throughout. Okay? So if you're accelerating by 1 meter per second for 10 seconds, okay, a constant acceleration of 1 meter per second for 10 seconds means that if you start at 0 meters per second, in the second you're going at 1 meter per second squared. You're going 1 meter per second, and then you're going 2 meters per second in the second, right? Then you're going 3 meters per second, and then in the 5th second, you're going 4 meters per second. Okay? Likewise, we can do the same thing if we have an acceleration of 2 meters per second squared. Then at time 0, if we start out, let's say we start out going 5 meters per second. Then in time 1, we're going to go 2 meters per second faster than that, 7 meters per second. And at time 2 seconds, we're going to go 9 meters per second. And then 11 meters per second. And then 13 meters per second. And then 15 meters per second. Each second, we're increasing our speed by 2 meters per second. That's what a constant acceleration means. It means that every second you're increasing your speed by the same rate. Okay. When an object is in free fall, it has a constant acceleration. Things are in free fall when they're accelerating due to gravity and only gravity. The acceleration due to gravity is 9.8 meters per second squared, or 9.8 meters per second per second. Okay? When you look at something, anything that's being dropped down, so it's falling because of gravity, every second is going 9.8 meters per second faster than the second before it. So at second 1, it's 9.8 meters per second. At second 2, it's 16.6 meters per second. At second 3, it's 29.4 seconds. At second 4, it would be 29.4 meters per second. And then it would continue to get faster and faster and faster. Okay? If you look at the graph of if you look at a time, or speed versus time graph, you'll notice that if the acceleration is constant, you get a straight line, because the speed is getting faster and faster and faster and faster and faster with each second. Okay. All right, here's what you should have in your notes. In your notes, you should have the definition of acceleration and the equation. You should have some examples for positive acceleration, speeding up, and positive acceleration, slowing down. You should have an example of negative acceleration, speeding up, and negative acceleration, slowing down. You should have several examples. You should have 4 example problems. You should know what's meant by constant acceleration, and you should know what free fall is. What the acceleration due to gravity is. You should have all of those things in your notes. If you do not have all those things in your notes, then please go back and listen again and add them, or write down a list of questions you need to ask so that you can get that information in class.